So for what we have done the standard electrode potential calculations. We have seen off cell potential. We have seen electrochemical series. We have seen galvanic cell, Daniel cell, and we have seen certain questions. So in this class, we'll study about the functions of salt bridge. We'll see the selection of electrolyte for salt bridge. Okay. Whatever the calculations of E cell for Daniel cell, complete cell representation, Nernst equation, we'll do in the next class. Okay. So we'll do these two today. Clear?
Yes, sir.
Yeah. So far you understood by using the chemical energy, how the electrical energy is generated. Yes or no?
Yes, sir.
Okay. But how can we get the sustainable current? That means if the chemical reaction, it's a very small process. So it will happen and it will generate certain chemical, some amount of electrical energy. But how can you keep it for so long that you will be continuously getting that electrical energy? How can we get that sustainable current? Okay. So that we're going to talk about. So tell me, we saw that there is a two cells, two half cells. Yes or no? What are those two half cells? Come on, guys, tell me, what are those two? Anode half cell, cathode half cell. Yes or no?
Yes,
So
sir.
tell me what happens in the cathode half cell?
Reduction, sir.
In anode?
Oxidation. Oxidation.
ఏం శరణ్ నోరు అసలు ఎప్పట్లేదు అని వస్తాయా లేకపోతే వేరే
No,
వాళ్ళు
sir.
చెప్తారులే ఊరుకుంటున్నావా?
No, sir.
Come on, everyone involved. Okay, so we know that there are two half cells are there. Now tell me, Sharan, how does these two half cells are connected? Okay, Mandara, how these two cells are connected? Srikar, how these two cells are connected?
Sir,
Uh,
by salt
no.
bridge.
Hmm?
Salt bridge.
Salt bridge and only salt bridge.
No, sir.
What about you, Srikar?
Yes, sir. Salt bridges. Salt bridges correct.
What about Banu? Is that only salt bridge or is there any other thing is there that's connecting the two cells?
So, porous partition, sir.
Hmm? Banu, come again.
Yes, sir. Sir, I can't remember it, sir.
Okay. What about you, Nitya?
So, the electrolyte and the salt bridge.
Electrolyte. This is electrolyte. This is electrolyte. This is electrolyte is part of the one half cell. This electrolyte is part of one half cell. I'm not saying, I'm asking how these are connected. You can see here, one is this one that's connecting this half cell. The other one is this one that's connecting the electrodes. Understood? The electrolytes are connected by the salt bridge and the electrodes are connected by the external wire. Is that clear?
Yes, sir.
So if I ask, how does the two solutions are connected? What is the answer? Two solutions are connected. What is by which? By what? The two solutions are connected.
So,
Salt.
salt bridge and metallic wires.
Only salt bridge. I'm asking, how does the two solutions? That means I'm saying, how does the electrolyte is connected? That only happened by the salt bridge. If my question is, how does the electrodes are connected? What is the answer?
Metallic wire.
Yeah, it is a metallic wire. Understood? Sharan, అర్థమైందా?
Yes, sir. Yes, sir.
So understand this, two solutions are connected by salt bridge. Remember this thing. So two solutions are connected by salt bridge. Now tell me, what is the use of this salt bridge?
To maintain neutrality.
How does it will maintain? I didn't explain that. Okay. So yeah, one is it will maintain the neutrality. How does it will do that? I didn't explain. So we'll see today how does it will do. So what is this? We studied every part of this except this salt bridge. Yes or no? We studied this zinc rod. We studied this copper rod. We studied about the zinc sulfate solution. We studied about the copper sulfate solution. We studied about how the oxidation happens. We studied about how the reduction happens. We studied about how this chemical energy producing the electrical energy and it's flowing through the wire. We studied. Yes or no? But I just told that salt bridge will maintain neutrality. But I didn't explain how does this will work. Understood?
Yes.
So how does the electrons will flow and generate the current? So everything we discussed. But in all, so far we discussed about the part where the current is produced by the chemical energy. But we didn't study about how does we stabilize this current? How does we produce the sustainable current for longer duration? So that is what the important role of salt bridge we'll see today. Is that clear?
Yes, sir.
Yes,
Yes, sir.
Okay. So let's say something about this salt bridge. So what is this salt bridge? Okay. So if you talk about the salt bridge, it is a very crucial component in the electrochemical cell. Okay. So it is very, very, very crucial. Why? It will provide the ionic connection and prevent the direct mixing of the solutions. Okay. So it provides ionic connection. What do you mean by ionic connections? That means it will provide the transfer of ions, either the cations or anions, to the electrolytes. Okay, I'll explain you in detail. Just now understand that it will provide the ionic connection while preventing. You will understand this statement when I'll explain in detail. Okay, so while preventing direct mixing of solutions. Here, solution in the sense, the solution in the anion half cell, the solution in the cation half cell. That is nothing but the ZnSO4 solutions, okay, and the copper sulfate solutions. You understood? So it will helpful for the exchange of the ions, but it will not allow the zinc sulfate solution to move to the copper sulfate or copper sulfate to move to the zinc sulfate. So prevent direct mixing of the solutions. Is that clear?
yes, sir.
Yes, sir.
Yes, second, yes, sir. Second thing, it is a U-shaped inverted tube. Remember this. It is a U-shaped inverted tube. So this tube, it is filled with a gel medium. Filled with gel medium. So this gel medium, it will contain an inert electrolyte. I'll explain why it should be inert electrolyte. Okay. So contain inert electrolyte, which is very, very important. Okay. And what is this inert electrolyte that we'll use here? It is the potassium chloride. So the inert electrolyte that we use here, it is potassium chloride. Okay, in agar jelly. Notice this as well. Potassium chloride in agar jelly. Okay, so remember the U-shaped invert tube filled with a gel medium that contains the inert electrolyte, which is a potassium chloride commonly used in a agar jelly. Okay, so I'll explain what is the use of this agar jelly, what is this inert electrolyte, why it should be filled with this gel medium. So why it is U-shaped? Okay, why it is designed in the U-shaped? So that it will ensure the proper connection between the two half cells. Okay, and maintain the physical separation. So remember, it was designed in such a way that it will make the connection between two half cells still maintain physical separation. Understood? So remember the U-shaped design, it will ensure the proper connection between the two half cells. Okay, while maintaining this physical separation. Is that clear?
Yes, sir.
Yes.
Okay, you can write it like proper connection between two half cells. Okay, so we are using here the gel medium, or you can say the gel matrix, that is nothing but the agarose jelly, or you can take some other jelly which is similar to this. Okay, why does this will do? Okay, what is the reason for this gel medium is it will prevent the bulk mixing of the solutions. Okay, so the bulk movement will be prevented here, allowing slow movement of these ions. Okay, so reason for the gel medium, the reason being prevents bulk mixing, while still allowing the ion movement. Is this clear? Why we are using the gel matrix or the gel medium?
Yes, sir.
Second one, we are using the potassium chloride. What is the reason for being? It is an inert electrolyte. So inert electrolyte. Why can't we just take any electrolyte? Why we are specifically taking this potassium chloride? The reason being, so we know potassium chloride, that's KCl, it will produce the K plus ions and Cl minus ions. Yes or no?
Yes, sir.
And if you take this potassium and chloride ions, they will move with a similar pace. That means the velocity of their movement is exactly or same. Okay, so they have a similar, this is very, very important. They have a similar mobility. Okay, so that I'll tell you what is, how does this similar mobility will be helpful in the coming slides. Okay, so this similar mobility, it will be helpful for minimizing the junction potential. I'll tell you what is this junction potential. So minimizing junction potential. Is that clear? So remember here the U-shaped, it will act like a physical barrier. How? So there will be no direct contact between these two electrolytes, between these two solutions, but still it will allow the movement of the ions. Okay, so what is this minimizing junction potential? First, suppose I told you there is a minimizing junction potential. So what is this junction potential, first of all? So this junction potential, it is also called as the liquid junction potential. So what is this? It is the electric potential difference developed between the two different electrolyte solutions. Okay, so remember the liquid junction potential or junction potential, it is nothing but the electrical potential developed, or you can say the electrical potential difference developed at the interface. Okay, that means at this cross bridge, at this salt bridge. Okay, so that's the one which is acting like an interface between the two different electrolytes. Yes or no? So if you see here, this is the one which is acting like an interface that is connecting these two solutions. Yes or no? So this is one different electrolyte, this is one different electrolyte. To both of these electrolytes, this is the salt bridge which is acting like an interface. Okay, so electrical potential difference developed at the interface, or you can say in this salt bridge between two different electrolyte solution. Is this point clear? What is meaning of junction potential? It's also called as the liquid junction potential. This is nothing but the electric potential difference that is developed in this salt bridge, which is present between these two different electrolyte solution. Okay, for suppose this one is having different electrolyte potential. This one is having different electrolyte potential. Yes or no? So these two differences will create certain potential at this salt bridge. So that we call it as the junction potential. Or you can say the potential that is present in this salt bridge. Okay, and we need to minimize this. What should we do? We need to minimize this. The reason being, so how does this minimizing will be helpful? One is it will be helpful for accuracy measurement. So if you are calculating any E cell measurements, you have to get this accuracy. So that accuracy can only be maintained if the junction potential is minimal. Okay, if there is a large junction potential, it can produce the errors in the potential difference between the electrodes. So your calculations will go wrong. That's the reason why Ola is blasting sometimes. You understood? I mean, those errors can happen. It's not this reason that because of that reason the scooters were burning out. Okay, so certain calculation mistakes can happen. Certain errors can occur if there is no accuracy. That accuracy cannot come if there is no minimizing junction potential. Junction potential will be there, but it should not be very high. It should not be very large. Okay, it should be minimum. Second one, it will create the stability of electrochemical cell. If there is a lot of junction potential, if the large junction potential is there, then it will affect the stability. Okay, it will affect the electrochemical cells.
So,
Yes.
so can you tell us what junction potential minimizing?
What is meaning of
Junction potential minimizing.
junction potential minimizing?
What does it minimize? So I didn't understand.
Okay. See, junction potential means, so if you see here, this is one electrolyte solution. This is another electrolyte solution. Okay, so this electrolyte solution contains certain potential. This one contains certain potential. Okay, the E naught value of here is different. The E naught value of here, it is different. And this is the rod that is connecting, that is acting like a bridge between these two. It is acting like an interface between these two. So being the difference here and here, there is certain potential is developed in this salt bridge. You understood this?
Yes, sir.
So this salt bridge has developed certain potential. That potential, we call it as the junction potential. Okay, if you see the junction potential difference, what it's saying, the electrical potential difference that develops at the interface that is present between the two different electrolyte solutions. Okay, understood?
Yes, sir.
So what is the reason is, why does it will produce? I didn't tell the reason. Okay, that's due to different mobility of ions in the solution. I'll tell you what is this different mobilities of ions in the solutions. But just understand that the reason is due to different mobilities of ions in the solution. Okay, for suppose tell me in the ZnSO4 certain ions are produced, here certain ions are produced. For suppose let's say here positives are produced, here negatives are produced. Okay, if there is a more positives and there is a less negatives, that will create a certain potential difference. Yes or no? That potential difference has to be maintained. How it will be maintained? Certain ions that are present in this salt bridge, they will move here and neutralize them. They will move here and neutralize them. You will understand that. Okay, so that due to different mobilities of ions in the solution, just understand that. We'll get back to this statement again. Is that clear? I'm trying to develop the concept. How does this junction potential works? Is it understood for everyone?
Yes.
How
Yes.
does it will affect the accuracy measurement? How does it will affect the stability of electrochemical cell?
Yes, sir.
And the third thing is, if you minimize, there will be reduced interference. So what does that means? So we know if you minimize this junction potential, it will reduce the unwanted interference in the electrochemical experiment. Okay, whatever this salt bridge is there, that salt bridge will not affect any chemical process. For suppose I told you this salt bridge is made up of potassium chloride. This potassium chlorides here, it will generate the K plus ions and Cl minus ions. K plus ions will move to one side, the Cl minus ions will move to other side, and it will neutralize. Okay, the reason being here it will split K plus, and those electrochemical cells where the negatives are produced a lot, this K plus will go and it will neutralize it. The electrochemical cell where Cl will go and neutralize the positive charges. Okay, but they should not interfere. Okay, if it is minimum, they will not interfere. If it is maximum, there's a chances for interference. Understood?
Yes, sir.
So reduce unwanted interference in electrochemical reaction. Clear? So you can see here, what is salt bridge? It is an inverted tube that contains a gel permeated with an inert electrolyte. Example, potassium chloride in agar jelly. You understood what is meaning of salt bridge?
Yes.
Yes, sir.
So what is the function? It connects the solution of two half cells to complete the circuit. One thing it will do that. We'll talk about it. Okay. So what it will do? It will connect the solutions. Okay. You can see here. It is connecting the two solutions. Okay. And it is completing the circuit. For suppose here the charge is flowing, the electrons are flowing here. Then what happens? It has to connect, it has to complete the circuit. Okay. Second thing, it maintains the electrical neutrality of the solution in order to give continuous flow or generation of current. I'll explain this. What is meaning of that? Okay. Let me see. Okay. So see here, the simultaneous electrical neutrality of the anodic oxidation chamber and cathodic reduction chamber is due to the same ionic mobility or velocity of K plus and NO3 ions taken into the salt bridge. You guys understood anything about this?
No, sir.
For suppose we are taking here the salt bridge. Actually, it's a KNO3. Okay, so let's take it. It's I mean KCl or KNO3. You can take any. So let's take for suppose. What is the main role that it is doing here? It is producing the electrical neutrality. Okay, so what is how does it do? So this electrical neutrality, it is happening between the anodic chamber and cathodic chamber, or you can say the anode off cell and cathode off cell. We know in anode oxidation will happen, in cathode reduction will happen. So that's how it is called as the anodic oxidation chamber and cathodic reduction chamber. So between these two, we need to maintain the neutrality. Okay, so that neutrality is accomplished by a specific ionic mechanism. I'll tell you that. Okay, so there's a specific ionic mechanism for this. That is the same ionic mobility or velocity of K plus and NO3 ions taken in the salt bridge. So what does that mean? You need to understand 3 points. One is, how does this specific ionic mechanism works? That works by equal ionic mobility of the ions within the salt bridge. So what are those ions? One is the K plus ions. The other one is NO3 minus ions. Or you can say the potassium ions and nitrate ions. This is nitrate ions. If you don't know what is NO3 minus. Okay, so remember what is this means? Equal ionic mobility of ions within the salt bridge. What does that means? That means whatever this K plus and NO3 minus are there in the salt bridge. So this salt bridge, it is made up of KNO3. So this K plus and NO3 minus, when they split, they will move exactly, or they will move with a similar velocity. Understood? So there is a, for suppose this salt bridge is made up of KNO3. So there is a potential difference as generated that will cause them to split out, K plus NO3 minus. Now, for suppose this electrochemical cell, it is containing positive. This electrochemical cell, it is containing more negative. So now what happens? The K plus will move to these negative ones. The NO3 will move towards the positive ones. So what it will do, all these positives will be balanced with the negatives. All these negatives will be balanced with the positives. That is only possible when it has the equal ionic mobility. That is a very, very, very crucial thing for the salt bridge. That's the reason why we can't take any salt bridge. We'll be taking a specific ones where the K plus and NO3, they have same movement or they have the same velocity. Okay. If they do not have the same velocity, what happens? What's the reason for using this salt bridge? In order to neutralize this negative charge with the positive, in order to neutralize these positive charges with the negative. But if I don't take the equal velocities, what happens? For suppose this K plus is moving very fast and this NO3 minus is moving very slow. So what happens now? There will be more positive this side and there is no neutrality this side. So again, the difference will be created. Is this clear?
Yes.
Yes.
Okay, so remember
Yes.
this thing. So they should have the same velocity. Okay, so this same velocity is very, very critical. Remember this, very, very, very important. Why? it will prevent the charge accumulation in any of these off cells. So you can write it like in either of off cells. Clear? Is that clear?
Yes. Yes, sir.
Yes, sir.
So
Yes, sir.
if this is happened, then what it will do for the cell? So it will maintain the continuous flow of current. That's the reason. Okay, I told you chemical reaction will happen that will produce the electrical energy. But in order to have this continuous flow of current, then if you want the sustainable current, then you need to create a salt bridge that will show this mechanism. Okay, then only what happens? So whatever the electrochemical reaction is happening, so this electrochemical reaction will proceed uninterrupted. Otherwise, it cannot happen. Understood?
Yes, sir.
Is this clear? So this
Yes,
is
sir.
very, very, very important.
Yes, sir.
So now read it. So it connects the solution of two half cells to complete the circuit. It maintains the electrical neutrality of the solution in order to give a continuous flow or generation of current. Now you understood what is the statement?
Yes, sir.
Yes,
Yes,
sir.
sir.
So next one. It ensures that two electrolyte solutions do not mix, but a slightly diffusion of ions from one electrode to another electrode is possible. Okay, so is that clear? So it is not mixing up the both the solutions. So whatever the solution present here, it is not mixing up with this solution, or this solution is not mixing up with this solution. Okay, but this cross bridge will allow us to move a diffusion of ions. Okay, so that's what we saw here. So whatever the ions are there, they can move, but whatever the solutions are there, these solutions cannot move through the cross bridge. So there is a slight diffusion will happen. That slight diffusion will happen based on this concentration gradient. Okay, is that clear?
Yes, sir.
Yes.
Yeah.
Yes, sir.
Yes, sir.
So once read this, try to understand. I'll explain in detail. Once everyone read this. Completed reading?
Yes, sir.
No, sir. Yes, sir.
Okay. So does anyone understood this? Nitya? Sharon?
I got disconnected. The first passage I understood, sir.
Okay. Banu? What about Shrikar? Mandara?
Yes, sir. Something
Yeah.
understood, sir.
Yes, sir.
Yes,
Tell
sir.
me what's something that you understood, Sharon?
So if I read, okay, it's understood, but I don't know that how to imagine like how it happens.
Okay. So see here what it's saying, from the salt bridge electrolyte, say KNO3. That means whatever the salt bridge that is present, here we made up with a KNO3. Okay. So here, this KNO3, I told you, it will split out into K plus and NO3 minus. Okay. So this K plus and NO3 minus, they will migrate towards the anode and cathode. For suppose the K plus will migrate towards the cathode. Okay. So where is the cathode in this? For suppose here we used, so this is the anode, right? The left one is anode, the right one is cathode. So remember, so which one is cathode, which one is anode? This one
The
is
left one is anode, right one is cathode, sir.
left is anode, the right is cathode. Okay, so see here, the K plus is moving towards the left, that is towards the anodes. Okay, that means the positive ions are moving towards the left. Why? The reason being here, accumulation of negative charges. The NO3 minus is moving towards the right. Okay, the reason being here, the positive charges are accumulated. Understood?
Yes, sir.
Is that clear?
Yes,
So
sir.
see here,
Yes,
so
sir.
cations, K plus, migrates towards the cathode. One second, guys. I think I wrote reverse. Okay, so the left is anode. So let's take NO3 and K plus. Okay, so see here, the K plus are moving towards the cathode. Okay, they are moving towards the right. So you can take them as negative charges. And here it is the positive charges. So in order to balance these positive charges, the NO3 are moving towards the anode. The K plus, they are moving towards the cathode. Is this clear? So cations migrate towards the cathode. So K plus is moving towards the cathode. And anions are migrating towards the anode. So they are migrating towards here. And polarize some of the oppositely charged ions in the solution. For suppose you will find here the minus ions. So that will be balanced by the K plus. So K plus will come here and balance them, these negative charges. And here the NO3 comes and balances them. So the NO3 minus will come and balance these. Here the K plus will try to balance. So you can take the K plus is trying to balance here. So those negative charges which are present here, it will be balanced by K plus, and those positive charges present here will be balanced by the negative ions, NO3 minus ions. Is this clear? So some of the oppositely charged ions in the solutions towards them, thus the cell keeps working and doesn't stop. Okay, but if there is no salt bridge, then there is no flow of electricity. Okay, because it is not a closed circuit. The closed circuit can attain when only you have this salt bridge. Then it will form the complete circuit. If you don't have the salt bridge, it will not form the complete circuit. Okay, so there is no flow of electricity after some time, because there will be an excess positive charges in the anode of cell, and there will be excess negative charges in the cathode of cells. Okay, so what happens if this is not balanced? There will be, on my left side there will be full positive charges, on my right side there will be full negative charges. Okay, so that the current will stop moving. You understood?
Yes, sir.
Yes, sir.
One thing
Yes,
is,
sir.
it will form a complete circuit that we studied here, somewhere here. So it connects the solution of and complete the circuit. You understood this? One is that reason. Second thing, if the salt bridge is not present, then there is no movement of K plus to balance these negative charges, and there is no movement of NO3 to balance these positive charges. Okay, in the anode and in the cathode. So what happens then? There will be here excess of positive charges, here the excess of negative charges, and there will be no current formation. Only for some time the current may flow, but after some time it will not flow. So in order to have the sustainable current, you need to have this cross bridge. Is this clear?
Yes, sir.
Yes.
Yes, sir.
It's
Yes.
okay. I'll explain in detail again. So just understand for better clarity. So see here. So salt bridge, again, it is very, very, very important in order to maintain electrical neutrality in the electrochemical cell. So there will be continuous flow of current. If the electrical neutrality is there, there will be continuous flow of current. That is what happening here. If there is no salt bridge, then what happened? There is accumulation of positive, there is accumulation of negative, then there will be no continuous current flow. So that's one thing. So how does this function will work? So function of salt bridge. So for suppose, let's say this salt bridge is made up of an electrolyte, or it contains electrolyte. Let's suppose say the KNO3. Okay, so this will perform two important purposes. One is, first it will form the K plus, the other one it will form the NO3 minus. So this K plus, what do we call? What is this K plus called? Which ion is this? Come on, say guys. Huh? It is a cations, right? And what about this NO3?
Anion.
Oh, no.
It is a anion, remember. Okay, so NO3 minus, it is a anion, and K plus, it is a cation. So what happens now, this K plus or cation, it will move towards the cathode. So remember, this cation moves towards cathode. Okay, so in our, what is the cathode? The right side, yes or no? So it will move towards the right beaker. And NO3 minus, which is an anion, it moves towards the anode, which is our left beaker. Understood? What is the main two essential purpose here? Formation of K plus, formation of NO3 minus. So this K plus is a cation, so it will move towards the cathode. NO3 minus, anion, it will move towards the anode. So what do we call this as? It is ion migration, which is a very, very important function of this salt bridge. Okay, so this movement will helps to maintain the electrical neutrality in both of cells. If there is no electrical neutrality, there is no sustainable current. So the current just produced for some time and then it will stop. So just imagine you have charged fully the battery, but then you use the vehicle, just moved 1 kilometer and then it stopped. The battery shows full energy, but it cannot move further. Okay, so this movement helps maintain electrical neutrality in both of cells. For suppose here more excess of positive charges are created, here excess of negative charges are created. If that is there, then there will be no current. In order to balance all these positive charges, then O3 minus will go here. So all these positive charges will be balanced with negative charges. So neutrality will happen here. All these negative charges balanced with positive charges. So neutrality will happen here. So that is how the ion migration that's happening from the salt bridge, it is very, very, very important for the sustainable current generation. Clear?
Yes, sir.
So what happens if there is no salt bridge? Let's say, for more clarity. Okay, so let's say if I am operating, okay, without salt bridge. So what happens if I'm operating without salt bridge? So no salt bridge is present. There will be several issues it can produce. One is what it will produce. Come on, guys, tell me what happens in the anode of cell. What happens in the anode of cell if there is no salt bridge? Come on, see here. What's happening in the anode?
So there will be more positive ions.
Yeah, there will be excess accumulation of positive charge in anode of cell. So what happens in the cathode?
There will be excess negative charge.
Yeah, so there will be excess buildup of negative charge in the cathode of cell. Okay, so now what happens? There is a imbalance. Okay, the charge imbalance is there. For suppose here it is positive charge. This half cell is positive. This half cell is negative. So that positive and negative will cause imbalance. Charge imbalance. So this charge imbalance prevents electron flow. So what happens then? The cell will eventually stops functioning. So cell eventually, whatever the electrochemical cell is there, it will stop functioning. Is this clear? Nitya, Mandara, Sharan, Srikar,
Yes.
Banu?
Yes,
Yes,
sir.
sir.
So what is the importance of salt bridge? Can you say from this? Can you summarize? What is the importance of salt bridge?
Electrical neutrality, uh, proper accumulation of both the charges.
So
Yeah.
it connects the solution of two half cells to complete the circuit.
Yeah. Okay. So this salt bridge, it will ensure the continuous cell operation. How it will do? First thing, by completing the electrical circuit. So that's one thing. So importance, if I say, first one is completing the circuit.
So it maintains the electrical neutrality, sir.
Yeah. So prevents the charge accumulation in half cell, in half cells. I mean both. Okay. So this prevent charge accumulation. So what happens? There will maintain in the whatever you said, charge neutrality throughout the system. So if you take this as an entire circuit, there will be no point where the positive is accumulated and point where the negativity is accumulated. So it will maintain throughout the neutrality. So this C is very, very, very important in order to make the electrons to move. If you don't put this, if there is a no maintenance of the charge neutrality, then the electrons will not move. Okay, electrons will not move. Electrons will not flow. So allow uninterrupted electron flow through external circuit or metal wire. Is this clear for everyone? What is the use of salt bridge? Now that is over, complete. The electrochemical cell is done. So now you understood what is the use of this electrode, what is the use of this electrode, what is this external wire, what is this salt bridge, what is the solution present here, what is the solution present here, how does the current is produced, how this current sustainably produced continuously without any interruption. Clear these points?
Yes, sir.
So if any
Yes.
question comes on the electrical cell, you are ready to answer, right?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, so just we'll summarize everything. So salt bridge, after the introduction of the salt bridge, electron neutrality is maintained as the counter ions are provided by the salt bridge. You understood what is meaning of counter ions provided by salt bridge? And the flow of charge takes place, the bulb will light up again. Okay, so criteria for selecting the salt bridge. You need to know few things. So which one we can take it like a salt bridge? We cannot take all the ions as salt bridge. Like why we are specifically taking here the KNO3. So see here, first, it should consist of cations and anions which have the same mobility. I told you, what is this? Should not react with the ions in the solution. First, suppose you see here, the NO3 is moving here, and there is some positive ions, these are negative ions. So these two should not make any other chemical compound here. They just come here, balance this positive charge, but it should not involve in the chemical reaction at the electrode. I told you, at the electrode, all the chemical reactions will happen and produce the positive ions. How the negative ions are produced in this electrode. But it should not happen. They just need to balance the positive charge, but they should not involve in the reaction. So should not react with the ions in the solution. Should not get oxidized or reduced at the electrodes. Is this clear? This point indicates this.
Yes.
Yes.
So salt
Yeah.
and yeah. So this is about, okay. So next one, salt bridge is not required for a galvanic cell in which common electrolyte of anode off and cathode off is present. Okay, you can take like a concentration cell. That's a type of special type of galvanic cell. So you will be seeing only in the electrochemical cell, but you will not be seeing here. So what is this galvanic cell? I already explained what is this galvanic cell. For suppose if you take the salt bridge is not required for a galvanic cell. Okay, even if a galvanic cell contains a salt bridge, the only thing that will maintain is complete the circuit, allows the ion flow. Okay, keeps the solution in separate off cell from mixing. That's what we saw, the use of salt bridge. But if you see the galvanic cell, here what happened? There is a common electrolyte of anode off cell and cathode off cell. That means the solution, whatever we are taking in the anode and cathode, both the solutions are same. Okay, but what is different here? For suppose if you take here, this is different solution, this is different solution. Yes or no? For suppose you see here. So here, this is ZnSO4 solution. Here, CuSO4 solution. The solutions are different here. But this is a Daniel cell. But what happens in the galvanic cell? So what happens in the galvanic cell? The electrolyte is common, but the amount of concentration, it is different. Okay, so remember, in galvanic cell, this is very, very important. They can ask questions on this. Okay, so in the galvanic cell, does the salt bridge is needed? Actually, not needed. Okay, why? Because it contains both the common electrolyte. It contains the same electrolyte in both the half cells. Okay, so remember, both half cells contain same electrolyte solution. So that is what he says, which a common electrolyte of anode and cathode is present. That means both half cells contains the same electrolyte solution. Okay, so this electrolyte solution can itself maintain the ionic balance. Can itself maintain ionic balance. You understood, right? For suppose, what happens here? As it is both are same solutions, what happens? If there is excess of positives are generated here, these negatives will go here. If excess of negatives are created here, these positives will go here. Because both are same chemicals. So it can move. They can have a direct contact. The solutions can contact with this solution can contact with this. But that can't happen in these cells. You understood? It can happen in the galvanic cell. So can itself maintain the ionic balance. So there is no need of, so this is the reason why no need of salt bridge. Is this clear? Then how does this works? For suppose if both are same solutions, then how does this works? This is working by the reason differ in concentration. Okay, so if you take one half cell, the concentration in this half cell is more compared to this half cell. So by this differ in the concentration, the cell is working out. So that's why it is called as the concentration cells, which is a type of galvanic cell, a special type of galvanic cell. Is this clear?
Yes, sir.
So why do we not need a salt bridge in the galvanic cell, and why do we need in the other? What is the other one? Name? Daniel. Don't forget the names, okay? So the other one is Daniel. Any doubts?
No, sir.
No, sir.
So selection of electrolyte for the salt bridge. Okay, so which electrolyte should we select? For suppose I told you here, we are using KNO3. Yes or no? Are we using KNO3? Yeah. We are using the KNO3. Okay, so why we are only using the KNO3? So generally a tube is filled with a paste of agar-agar powder with a neutral electrolyte. Okay, generally it is not common to anodic or cathodic compartment with porous plug at each mouth of the tube. So what does that means? So what does this means? For suppose you are taking an electrochemical cell, a Daniel cell, so electrochemical cell. So this electrochemical cell, it contains the anodic compartment, that's nothing but the anode of cell, and it contains cathodic compartment, that means cathode of cell. So typically they should not be mixed up. So typically they should not be mixed up, that we saw. So what is that means? They should prevent the direct mixing up of the electrolytes and the reactants. But still, we will be using a porous flux. That means we are taking a slight porous ones. Okay, porous, so that certain ions can move and neutralize them. So is this clear? So generally it is not common to anodic cathodic compartments with porous plugs at each mouth of the tube. Okay, so what is that means? Electrochemical cell is there. That's an anodic compartment, cathodic compartment. They typically should not be mixed up. That means whatever the anions are there and whatever the cations are there, or the positives and negatives are created, they should not get in contact. Okay, so that's the reason why we should not, there is a not needed for the porous plugs to use. Okay, actually not common to anodic cathodic compartment with porous plugs means there is no need of this method, but still we use, the reason being, so whatever these are formed, they can move. For suppose, let me show you. The ions of the inert electrolytes do not react with the other ions in the solution, so the ions are not oxidized or reduced at the electrodes. Understood this? This one? Not common to
But can you
anodic
show
or...
the previous slide again, sir?
What one? Yeah, that I'll explain. Actually, that's not related with this. That's the reason I came back again. So generally, it is not common to anodic or cathodic compartment because there is a no need of direct contact. So typically should not be mixed up. So no need of porous plugs. Okay, so it's not necessary. That's what generally it is not common to anodic or cathodic compartments with a porous plugs at each mouth of the tube. So they don't need to have this flow. Porous means what they will do, they will create a small connection so that this electrochemical or this electrolyte will mix up with this electrolyte. But we don't need that one. Next one. So next one, see here. So selection of this is one reason. Okay. Second one, the ions of the electrolytes do not react with the other ions. Okay. So whatever for suppose we are using KNO3, so it is producing the K plus and NO3 minus. So these K plus should not react with the negative ions present in the electrochemical cell. Again, the NO3 minus, they should not react with the positive ions present in the electrochemical cell. Okay, so when they react, they can get the oxidized. When they react, they get the reduced. So that should not be happen. So the ions are not oxidized or reduced at the electrodes. That means they will not, this means should not participate in chemical reaction. So that is why we should use the inert. We say inert gases, why? Because they will not involve in any reactions. The same way we say here inert electrolytes, that means they are not involving in the electrochemical reactions. Is this point clear?
Yes, sir.
So this
Yes.
is the second needed. The third one is the electrolytes in a salt bridge should be such that the speed of cations is equal to the speed of anions in an electric field. Okay, so I told you this, whatever the K plus are formed and NO3 minus are formed, they have the equal speed. They will move equally. So that this K plus will move and balance these negatives, then NO3 will move and it will balance the positives at same pace. If one is going so fast, the other one is not going so fast, then what happens in this chamber, the neutralization will happen. But in this chamber, the neutralization couldn't happen. So again, it will interrupt the electrochemical cell, the flow of electrons. So both should do at the same time. For that, you should need electrolytes which will move at same pace. Understood? At same speed. So KCl is generally preferred, but KNO3 or NH4NO3 can also be used. Okay. So we can use KCl, we can use KNO3, we can use NH4NO3. So we know K plus NO3 minus, NH4 plus NO3 minus, K plus Cl minus. Understood?